Dear friends, today we will discuss the topic Basic Programming Model and Application Instruction Set Part 2. What is the new in the 8036 DX? Data bus, which is also of the 32-bit registers are of the all are the registers are of the 32-bit. Flags also are of the 32-bit. Address bus are also of the 32-bit. 8036 has an enhanced memory management unit. 8036 supports virtual addressing. It has a faster executions of arithmetic operations. 8036 works on a real mode, protected mode, virtual mode. In additional to interrupt, it has a IVT, that is an interrupt vector table. The features of the 8036 are it has manufactured using the Intel complementary high performance metal oxide semiconductor. It has a 8 general purpose registers are of the 32-bit, a 32-bit address and a data bus. It supports 8-bit, 16-bit, 32-bit data. A prefetch queue is of the 16-bit. A very large address space, that is a VM of a 64 TB and a PM of the 4 GB. It supports virtual memory of the 64 TB and a page memories of the 4 GB. Supports a segmentation and a paging. 80386 supports paging and a segmentation. It has a 8 general purpose registers are of the 32-bit. It prefetches queue. It has a prefetch queue of the 16-bit. A 4-level protection. It has a 4-level protections. It uses a three-stage pipelines. It uses a three-stage pipelines. It supports multitasking with the protection. On-chip cache memory of the TLB. It has a on-chip cache memory of the TLB. Pipeline instruction execution. It can pipeline instruction execution. It supports. It has a enhanced memory management unit. It has a high-speed numeric supports via 80287 and 80387 coprocessor. It can operate in a real mode, protected mode, and a virtual mode. These are the features of the 80386. Family tree of the 8086. As we see in the figure, 808, 8088 in 1978, 8088 in 1982, which has a data bus of the 16-bit, address buses of the 20-bit. 8086 is introduced in 1983 as a data bus of the 16-bit, address bus of the 24-bit, and a memory of the clock speed is high. A 386DX was introduced in 1986, or a SX model is introduced in 1988. It has a data bus of the 13-bit and SX has a address bus of the 32-bit and a 24-bit. 80486, which is has a data bus of the 32-bit and address bus is also of the 32-bit. Memory size is a 4G. So what is the difference between the 80386 SX and a DX model? A 386DX consists of the 32-bit address bus, whereas the 80386 SX consists of a 24-bit address bus. 80386DX consists of the 32-bit data bus, whereas the 80386 SX consists of the 16-bit data bus. Package in a 132-pin PGA 100-pin flat packages. Addresses of the 4G memory, 4 GB of the memory, and 16 MB of the memory. 80386 can package in a 132-pin PGA model, whereas the 8036SX package in a 100-pin flat package model. 8036 supports a 4 GB of the memory, whereas the 8036SX supports a 16 GB of MB of the memory. Both have same international architecture, lower cost packages, easy of the interfacing to 8-bit and a 16-bit memory and peripherals makes 6 suitable SX is suitable for use in low cost system. Is used in a low cost system. SX suitable for a use in a low cost system. So what is the 386? 386 is an advanced 32-bit microprocessor optimized for multitasking operating systems and designed for applications needing very high performance. 80386 is an advanced 32-bit microprocessor. A 32-bit registers and data path supports a 32-bit addresses and a data types. The processor can address up to the 4 gigabytes of a physical memory and a 64 terabytes of a virtual memory. The on-chip memory management facilitates includes the address translation register, advanced multitasking hardware, a protection mechanism, and a page virtual memory. A special debugging registers are there, provided data and a cache code breakpoint even in a ROM-based software. Features of the 386. 386 has a 3 processing modes: protected mode, real mode, and a virtual. A protected mode is the natural 32-bit environment of the 386 processor. In this mode, all the instructions and features are available. In a real mode, that means a protected mode, which is a mode in which a 386 works in its natural environment, means on which it is built of, that is of 32-bit environment, a 386 process. In this mode, all the instructions and features are available. Whereas in a real address mode is the mode of the processor immediate after the reset. Then after the reset, a 386 enters into the real mode. In the real mode, 386 appears to be programmer as a fast 8086 with some new instruction, or we can say most application of a 386 will use a real mode. Most of the applications of the 386 use a real mode. In a real mode, 80386 works as a 8086, that is we can say a fast 8086 with a new of the instructions. A virtual 8086 mode. Virtual 8086 mode is a dynamic mode which can switch repeatedly and rapidly between a virtual 86 mode and a protected mode. The CPU enters the V86 virtual 86 mode from protected, then leaves a virtual 86 mode and enters the protected mode. The architecture is as shown in a figure. It has a segmentation unit, paging unit, bus control unit, instruction prefetch, instruction precode, control unit, the internal architecture of the 386 is divided into 3 sections: central processing unit, which has execution unit and a instruction unit, whereas the memory management unit consists of the segmentation unit and a paging, and a bus interfacing unit, a central processing unit. The central processing unit is further divided into execution unit and instruction unit. Execution unit has 8 general purpose and 8 special purpose registers, which are either used for holding data or calculating the offset addresses. The instruction unit decodes the opcode bytes received from the 16-byte instruction code queue and arranges them in a 3-instruction decoded instruction queue. The execution unit is of the 8 general purpose register. The instruction unit decodes the opcode bytes received from the 16-byte instruction code. The central processing unit is further divided into the execution unit and a instruction unit. Execution unit has 8 general purpose registers and 8 special purpose registers, which are either used for holding a data or for calculating a offset addresses. The instruction unit decodes the opcode byte received from the 16-byte instruction code queue and arrange them in a 3-instruction decoded instruction queue. Thank you friends for watching the video.